Okay, today as we continue, we're doing Chapter 1, Section 3, which deals with equivalent algebraic expressions. To give you some background on this, first of all, what is an expression? Well, if you have like 2x plus 3y plus 6, this is an algebraic expression. Now, if you were to take out this plus sign and put an equal sign there, then this becomes an equation. The presence of an equal sign in a series of terms makes it an equation. Without the equal sign, it's just an expression. So what we're doing here is we're going to look at equivalent algebraic expressions. And what they're doing in examples 1 through 7 is they want you to become familiar with these basic, they're calling them laws: the commutative law, the associative law, the distributive law, and then this is actually a process, factoring. So I'll just give you a little background, and then you're going to have to apply as you do the answers, keeping in mind they are in the back of the book, or back of the chapter. So in the commutative law, we have A plus B equals B plus A. Well, they're the same terms, but they're in different order. They've been switched. And we can add A to B or B to A. We get the same answer. That's why they are called equivalent expressions. This is the commutative law of addition because of the plus signs. Now, if you had AB equals BA, these are factors now, and this is multiplication. But again, the same factors just switched around. This is the commutative law of multiplication. Now here we have A plus B plus C equals A plus B plus C. And you might say those are identical. But in the associative principle, we're saying we can put a parenthesis around the A and B, and that is to add these two terms together, then add C. Or we can put the parenthesis around these, which indicate add these two terms together, then add it to A. And the results are going to be the same, because they are equivalent algebraic expressions, but this one is illustrating the associative law of addition, and the same applies to multiplication. Here they're exactly the same, but now we're saying multiply these two first, then that, or multiply these two first, then that. And the distributive is A times B plus C. And we are distributing through multiplication. A times B is AB, plus A times C is AC. So this would be an example of the distributive principle or law as they're describing it in our book. Now, this last one, factoring, is a process in which you notice that in this term and this term, there is the common factor A. So they want us to factor out the common factor. So normally what we do is we put a set of parentheses there, and we're going to factor out this common A, and then what we're left with is B plus C. So in a sense, the reverse of the distributive law is factoring. So we go from here to there, or from there to there. And 1 through 7 is your challenge, and see if you can recognize which of the principles that are there. Okay, as we go on to some of the other examples, we see in 7 and 8, they're asking us to illustrate the commutative principle, starting off with this. So basically, commutative, we're going to switch things around. This is one factor, this is another factor. So it would be n times negative 8m. And here, commutative would be to switch the order, 10 plus CD. Now here, they want us to use the associative principle. So we want to keep the same order. We're going to go 7 plus x plus 2x. So we'd want to do that, kind of do the x's together. And then for this one, the associative would be negative 4, and then RS. Okay, in this next few examples, we're asked to sort of simplify, and keeping in mind these basic laws that we're using. So for this one, we could switch the 3 and the n around. Then that would give us 6 plus 3 plus n. And then when we simplify that, that's 9 plus n. And this one, you can switch these two around, so you'd end up with 4 times 5y. And then 5, and a 4 times 5 is 20y. Again, we're allowed to do that. We can switch these around, and then our 4 and 5 are together. Now here, again, we're switching the 7 and the 4. 4 times 7, b. So 4 times 7 is 28b. And here we're going to regroup 3 plus 15 plus y. And that's then 18 plus y. And these are skills we often take for granted, and we just do them normally. But the rules are there, and it's legal to do that. Okay, continuing on number 15, they're asking us to use the distributive principle, and we need to watch the sign. That's going to be a negative 2x. Now a negative 2 times 3, that's going to be a negative 6y. And check your work. This times this, negative, this times this, negative. That's good. Again, we're going to distribute that 8w, so 8wx plus 8wy minus 8wz. Now notice for each of these, after we distribute, by reversing it through factoring, we would get what we have on top. So these two processes often go together. Now here they want us to factor for these 4. And as we look at the 2 terms, we're going to need a parenthesis for 2 terms, and then we're going to factor something out of each of these. And it would be a 4. Now if you distribute, you want to get to what you started with. Now notice you could take a 2 out of each one, but that wouldn't be the greatest common factor. You could take a 5 out of each one. But the greatest common factor out of each one is 10. Leaves you with an A. And you can always check by reversing what you've done to see if you get what you started with. Number 19, as you look at both terms, you want to factor out the common n. So you're left here with an m minus 2. And in number 20, I see a 22 there, so you can factor out a 22. And you're left with a 10m here, minus, well, 22 times what is a negative 22? A negative 1. Sometimes students forget to put the 1 there, and then if they tried to distribute this, they wouldn't get that answer without the negative 1 there. That's why it's important to check things. As we finish up this lesson, we're getting to something that's called like terms. And what is a like term? Well, by definition, a like term is any term that has, in a sense, the same variable. So something whose variables were x squared as a variable, these would be like terms. You might have like 3x plus 5x squared, of course, minus 2x squared. These would be like terms because the variable is exactly the same. And basically what you're going to deal with are the numerical coefficients of these terms. And one of the exercises, they also ask you to list the terms. So here, one term would be this, you put a comma. Another term would be a negative x. You'd separate the terms by a comma. Normally, terms are separated by either a positive or negative signs. Now, since this starts with a negative, you have to write the negative. If you're starting with a positive, they don't usually write the positive sign. So, as we combine like terms here, that'll be our next little item. So here we have 7x minus, and a good idea is to put a 1 there, 1x. This is going to be a 6x. Now here we have 3 of AB's and 6 of AB's, which will give us 9 AB's. And here's a case where you may want to combine your negatives first. This gives you a negative 11t plus 4t. And some of this you can do mentally. This is going to give you a negative 7t. And you could have done it this way. This gives you a negative 3 from 4 is 1t. 1t from a negative 8, a negative 7t. But again, the idea that you can do this first, associate these two, and then do the other. Probably a good idea. Okay, now here, this is a like term, and this is a like term, but there's no other one that's like that. So it's going to be 11 minus 5 is 6x plus x squared. Like terms. Again, you're going to be working on your practice and quiz bees and try to stay up to date, because if you let it lag, that gets to be a problem when you're trying to cram. So little by little is the best way to do it.